Okay, so let's do that then. Okay, so what I just said a second ago is what's in the absolute value can be what's outside it or its opposite. Okay, so what's inside the absolute value here? 3x minus 2 could equal what? Could equal
4.
Or 3x minus 2 could equal what? Negative 4. And I know it's a little bit of writing, but I would really encourage you to write it down like that. It's easier, it's less confusing. It's a little more writing, but it's less confusing if you do that. Okay? All right, so we add 2 to each side. So 3x is 4 plus 2, which is 6. 5 by 3. X is 6 5 by 3, which is 2. And be careful. Some students say, oh, the answers are 2, and then the other answer is going to be negative 2. Not necessarily. If we add 2 here, negative 4 plus 2 is negative 2. 5 by 3. So the answer is negative 2/3. So negative 2/3 or 2. And there's 2 answers, and you need both answers. Now, with that being said, good, you like this next one. That little trick I just showed you over there, what's inside the absolute value, could be what's outside it or its opposite. Gotta be careful on that one, okay? You'll like number 27, okay? 27, we have 3, absolute value of x plus 1 minus 2 is negative 11. What do you think we ought to do first? Plus 2. Trying to get the absolute value by itself. So 3 absolute value of x plus 1 equals negative 9. Then what? Is it by itself now?
No, divided by 3.
Right, because 3 absolute value means 3 times the absolute value. Some students ask, can we distribute that? Be careful. Absolute values are kind of like parentheses, but not exactly. So I would divide by 3. Divide 3, divide 3. So absolute value of x plus 1 equals negative 3. Here's where you got to be careful, okay? What I just said was what's inside the absolute value could be what's outside it or its opposite. So, am I saying x plus 1 could be negative 3 or x plus 1 could be the opposite of that? Is that what we do here? Short answer is no. Okay, that doesn't really work. Here's why. What do you get when you take the absolute value of something? What kind of a number? Except for what? No. There's one number you take the absolute value of, you don't get a positive. 0. What's the absolute value of 0? 0. If you take the absolute value of something, it's gonna equal a positive number, except for 0, okay? So if I said this right here, absolute value of x is negative 3. What can I take the absolute value of and get negative 3? What? Nothing. You can't take the absolute value of something and get a negative. So, what can I take the absolute value of and get negative 3? Nothing. That little trick about what's inside it, can be what's outside it or its opposite, only works if this number out here is a positive. So the answer here is, there's no solution to that. And be careful. Some students say no real solution. You gotta be careful if you wrote no real solution. If you say no real solution, it's kind of implying what? That maybe, what? And there's not even imaginary solutions. There's no solution. Okay, last one, number 29, last one we're going to do right here. 29, 9x3 minus 18x squared, that's 4x plus 8. Okay, I don't know if I told you guys this yet or not this year. In Algebra 2, I told you quadratics are always supposed to equal 0. That's nothing new. Second degree should always equal 0. The very first question we did today, I think it was, I said it equaled 0, and I said, is that a good thing? You guys said yes. Quadratics are supposed to equal 0. That's not wrong, but I should say anything second degree or higher should equal 0. This is not a quadratic, this is a cubic. It equals 0, okay? That's a good thing, okay? You guys remember how to factor when we have 4 terms?
2, you group them.
Group them, 2 and 2. What can I factor out of 9x3 and 18x squared? 9x squared times what is 9x3? 9x squared times what's 18x squared? What can I factor out of those?
4.
Careful.
Negative 4.
Why negative 4?
That's the sign.
Because this first one's negative. So negative 4 times what?
X.
Negative 4 times what gives you positive 8?
Negative 2.
Okay, step back. Do you like what we got so far?
Yes.
Why?
That's the inside of the thing.
they're not, there's something probably wrong. How many x minus 2s you got here?
X. 9x squared.
How many here?
Negative 4.
So you have 9x squared minus 4, x minus 2s. Does that factor any further?
There's a difference. X squared.
Yeah, what's that?
3.
3 what?
X squared.
Well, what squared? 3x, don't say squared. What squared? 2. So 3x plus 2? Yeah, 3x minus 2 equals 0. So my, oops, left something out. X minus 2. So our answers are negative 2/3, positive 2/3, and 2. One last thing before we do our homework quiz. Is it imperative? I haven't been checking my answers here. The first couple of problems we checked our answers. Is it imperative that do we have to check our answers on this problem? No, you don't have to. It's a good idea to. You know, should. I don't make you guys, but you don't have to on this one. Why was it necessary to check your answers back on like questions number 13, like number 13? Why did we have to check our answer? We had to check our answer. And if we didn't, we would have got it wrong. You guys remember? If I give you a problem such as this, do you need to check your answers on a problem like that?
Yes.
Yes, no, you don't. You don't have to. You don't need to. You can. You don't need to. I give you this right here. You have to check your answers on that problem when you're all done. Why? See what, where?
So you can't get it. 3.
So when you do all this, I have no idea what the answer to this problem is. No idea. But it better not be what?
3 and then.
If I get an answer of 3 or negative 5, what do I do with them? Cross them out, okay? Why don't we have to check our answers on this one?
Because there's no action.
There's no x's on. Well, even just because it's a fraction? What if I give you this? You have to check your answers on that one? Nope. A fraction with what, where? X's on the bottom. You got to check your answers if x is on bottom because you might have 0 on bottom if that's the case, okay? All right. We're done for today.